Ever look up at the night sky and wonder, are we really all alone out here?
It's a question that's captivated humans for millennia,
Well,
right?
totally. And today we're diving into some of the biggest cosmic mysteries that have scientists doing the same thing.
Oh, yeah, these are the puzzles that really keep you up at night.
Exactly. You sent over some seriously fascinating articles about strange signals from space.
Signals that just don't quite fit with what we think we know about the universe.
So, our mission, if you choose to accept it, is to unpack 10 of the most mysterious signals ever detected.
Some were just these fleeting blips,
And others, well, they keep repeating.
but they all make us ask, what else is out there?
Right, is someone out there trying to get our attention. All right, let's get started.
Definitely. A good place to begin might be with the wow signal.
Yeah, the wow
Wow.
signal. I remember reading about that. It's one of those stories that really captures the imagination.
Totally. It was back in 1977, August 15th to be precise.
Okay.
Jerry Amon, an astronomer at Ohio State University's Big Ear Radio Telescope, was looking at data from the telescope.
Weeshoo.
Yeah, part of the SETI program, and boom, there it was.
What, like a giant flashing red light?
Not quite, but close enough in terms of excitement. It was this 72-second blast of radio waves.
72 seconds. That's pretty brief.
It is. But in those 72 seconds, it packed a punch. Way more intense than anything they'd ever picked up before.
Interesting.
And here's the kicker. It had characteristics that looked artificial. Like it wasn't just some random cosmic event.
Really? So what did they think it was?
Eamon was so surprised by the signal that he circled it on the printout and wrote, you guessed it, wow.
I mean, I'd probably write wow too if I saw that, but where did the signal come from?
That's part of the mystery. The direction points to the Sagittarius constellation.
Okay, but Sagittarius is a pretty big place.
It is, and that's the thing. There wasn't any known star system in that specific spot where the signal seemed to be coming from.
So a powerful, possibly artificial signal from, like, the middle of nowhere. That's strange.
Strange is an understatement. What made them think it might be artificial, though, was how narrow the signal was
Narrow.
in terms of the frequency band it occupied. Natural radio signals tend to spread out across lots of frequencies.
Okay, so this one was more focused.
Exactly. Like a beam. That kind of focus is what you'd expect from a deliberate transmission.
That's really interesting. So what happened next? Did they pick up any other signals from the same spot?
That's the biggest head-scratcher with the wow signal. Despite tons of follow-up searches over the years, using all sorts of telescopes, it's never shown up again.
Wow, so it's like a cosmic one-hit wonder?
Yeah, and that makes it super tough to figure out. Could it have been a glitch, some kind of terrestrial interference they missed at the time?
Or was it a message from some distant civilization that, for whatever reason, decided not to call back?
We might never know. But the wow signal really shows you how hard it is to make sense of these one-off events.
Makes you think, maybe there are other signals we've missed or haven't even been able to detect.
Absolutely. Okay, so let's move on from a potential single message to something far more brief and energetic. Fast radio bursts.
Or FRBs for short. Yeah, I've heard about these. They seem to be all over the news these days.
They are, and for good reason. The first one was officially reported in 2007, though the actual signal was from 2001.
Okay.
Since then, we've found hundreds of them. They're intense pulses of radio waves, but here's the catch. They only last milliseconds.
Milliseconds, like a fraction of a second.
Yeah, incredibly short. But the amount of energy they pack into that tiny time frame is enormous.
It's got to be something pretty powerful to create a bird like that, right?
Right. And scientists are still debating what exactly causes them. The leading contenders are neutron stars.
Those super dense, collapsed stars.
Yeah, or maybe even black holes, especially if they are involved in some really energetic events.
Every time I hear about black holes, my brain just kind of melts a little.
I feel you. They're mind-boggling. And some folks even speculate that maybe, just maybe, some FRBs could be related to alien technology.
Alien technology? Like what, their version of radio signals?
Could be, or something related to propulsion, maybe even interstellar travel.
That would be something.
Right. But it's important to remember that, for now, natural explanations are still the most likely.
Okay, so we've got these super powerful, super short radio bursts coming from all over the cosmos. Are they all one-offs?
Actually, no. That's what makes FRB so fascinating. Some of them do appear just once, but a growing number of them are repeaters. They fire off multiple bursts.
Like a cosmic Morse code.
Kind of. And a really famous example of a repeater is FRB 121102. This one's been flashing on and off for years.
Years. That's a long time for these kinds of signals.
Yeah, it is. And that means scientists have had more chances to study it, which is helping them understand FRBs in general.
Gotcha. So before we move on to the next signal, I wanted to ask about another powerful burst that was detected back in 2001.
You mean the Lorimer burst?
That's the one. It was actually detected before FRBs were even a known thing, right?
Yeah, that's right. It was named after Duncan Lorimer, the guy who discovered it while looking through old data.
So it was just sitting there in the archives waiting to be found.
Pretty much. And it was so strong, so unlike anything they'd seen before, that they thought it must be a mistake.
Like a glitch in the system.
Exactly. But then, as more FRBs were discovered, they realized that the Lorimer burst was probably the first one they'd ever caught.
It's a trendsetter.
You could say that.
Yeah.
And get this. The signal is estimated to have come from billions of light years away.
Billions. So that signal was traveling through space before Earth even existed.
Mind-blowing, right?
Totally. And how much energy are we talking about here?
In that split second, the Lorimer burst released more energy than our sun does in like a really long time.
Seriously?
Yeah, it was huge. And it made scientists ask, what in the universe can create that much energy so quickly?
It really makes you realize how much we still don't know about what's out there.
No kidding. It's humbling, but also exciting.
Definitely. Okay, let's shift gears a bit and talk about a signal that's a lot closer to home. In 2019, there was a signal picked up from Proxima Centauri.
You're talking about the Green Bank signal.
Yeah, that's it. Proxima Centauri is the closest star system to us.
Right, it is. And it even has a planet, Proxima b, that could potentially be habitable.
Wow, so this signal is coming from our next-door neighbor, cosmically speaking.
Exactly. And it was picked up by the Green Bank telescope in West Virginia.
So what was so special about this signal?
Well, first of all, the frequency. It was at 980 megahertz, which is not a frequency that's typically used by our technology. And it didn't look like any kind of natural interference that they could identify. It had a really specific structure.
So could it have been?
An artificial signal? Possibly. Some scientists cautiously propose that it might be from a technological source.
Now that would be huge. Imagine our closest star system has a civilization that's sending out signals.
Right. But we have to be careful. We haven't ruled out natural explanations yet.
True, true. Extraordinary claims require extraordinary evidence, as they say.
Exactly. But even the possibility is enough to get people thinking.
No doubt. It really makes you wonder, if there is life out there, how common is it? How often does it evolve to the point where it can send out radio signals?
And are we even looking in the right places? Using the right methods?
Big questions. Okay, let's move on to a star that has become a bit of an internet sensation because of its strange behavior. Tabby's star.
Ah, Tabby's star, or KIC 8462852 if you want to get technical. This one really captured people's imaginations back in 2015.
I remember hearing about it. What was it doing that was so weird?
Well, it was dimming, which isn't unusual for a star, but this was different. It was dimming a lot, up to 22%. And it was doing it in these random, unpredictable patterns.
22%, that's like a fifth of the star's light just disappearing.
Yeah, it was massive.
Yeah.
And no one could figure out why.
So what were some of the theories?
Well, some people got really creative. There was talk of alien megastructures.
Alien megastructures?
Yeah, like a Dyson sphere, a hypothetical structure built around a star to capture its energy.
That's some serious sci-fi stuff.
It is. But most scientists thought that was a long shot. Other explanations focused on natural causes, like maybe a giant cloud of comets or some weird kind of dust.
So did they ever figure out what was going on with Tabby's star?
Not conclusively. They looked into the comet idea pretty seriously, but it didn't perfectly explain everything, so it's still an open question.
Another cosmic mystery. I'm sensing a pattern here.
Definitely. The universe likes to keep us guessing.
So back to the search for signals. In 2003, a project called SETI at Home picked up an intriguing signal labeled SHGB02 plus 14A.
Ah, yes. SETI at Home is pretty cool. It uses the computing power of volunteers all over the world to analyze data from radio telescopes.
Crowdsourcing the search for aliens, I like it. So what was special about this signal?
Its frequency. It was right around 1420 megahertz, which happens to be the same frequency as the radio emissions from neutral hydrogen.
Hydrogen, like the simplest element in the universe.
The very same. And a lot of scientists have thought that if an alien civilization wanted to make contact, they might use that frequency.
Because it's like a universal language that everyone would understand.
Exactly. It would be like a cosmic, hello, is anyone out there?
I love that idea. So did they ever hear from whoever sent that signal again?
Unfortunately not. The signal appeared a few times in the data, but it was pretty faint.
Okay.
And when they looked at the spot in the sky where it came from, there weren't any stars or planets there.
So another signal from seemingly empty space.
Yep. It could have been a genuine attempt at contact, or maybe just a weird glitch.
The mystery continues.
It does. Okay, ready for something really massive.
Always. Hit me with it.
In 2020, astronomers discovered these giant X-ray bubbles coming from the center of our galaxy.
X-ray bubbles. That sounds kind of ominous.
They're definitely impressive. These bubbles are huge, thousands of light years across.
Thousands. Our entire solar system is just a tiny speck compared to that.
Exactly. And they're filled with high-energy particles, which is why they show up in X-ray observations.
So what do you think created them?
Well, the prime suspect is the supermassive black hole at the center of our galaxy.
Of course it's a black hole. They always seem to be involved in the coolest stuff.
Right. These bubbles might be the remnants of some ancient outburst from the black hole, a time when it was much more active.
So our galaxy has a bit of a wild side, huh?
Oh, yeah. It might look calm and serene from our vantage point, but there's a lot of energy and chaos going on in the center.
Well, as long as those black hole outbursts don't head our way, I'm good.
I think we're safe for now, but it's a reminder that our galaxy has a history, and it's probably a lot more dramatic than we imagine.
Definitely. Okay, let's talk about another space telescope, the Kepler Space Telescope. It was designed to find planets, right?
That was its main mission, yep. To look for exoplanets by watching for tiny dips in a star's brightness when a planet passes in front of it.
Makes sense. So did it find any planets?
Thousands of them, actually.
Like-
Kepler was a huge success. But it also picked up some signals that were a bit off.
Off how?
They didn't look like normal planetary transits. These were weird, irregular dips in brightness, not at all what you'd expect from a planet passing by.
So what did they think was causing them?
Well, some people, of course, jumped to the alien megastructure idea again.
Dyson spheres, part 2.
Exactly. But more likely, explanations involved things like clouds of dust or maybe comets breaking up near the stars.
So another case of we're not really sure.
Yep, another cosmic puzzle to add to the list. But that's part of what makes science so fun, right?
Totally. Always something new to discover.
Mhm.
Okay, last and not least, tell me about the Breakthrough Listen BLC1 signal.
Ah, yes. This one came from the Breakthrough Listen project, which is specifically focused on finding evidence of extraterrestrial intelligence.
So they're actively searching for alien signals.
Yep. And in 2020, they detected this signal coming from Proxima Centauri.
Again, Proxima Centauri seems to be quite the busy place.
It does, doesn't it? And this signal was particularly interesting because it lasted for several hours.
Hours. That's way longer than those millisecond-long FRBs we talked about earlier.
Right, and it was a very narrow signal in terms of the frequency band it occupied.
Okay, remind me why that's important.
Because artificial signals tend to be narrow. If you're trying to transmit information across vast distances, you want to focus your signal as much as possible.
So it's less likely to get lost in the cosmic noise.
Exactly. So this BLC1 signal, lasting for hours and being so narrow, got a lot of people excited.
Did they confirm it as an alien signal?
Not yet. They're still analyzing the data, trying to rule out every other possibility.
So another one for the maybe file.
For now, yeah. But it just shows you that the search for extraterrestrial intelligence is ongoing, and we're getting better at it all the time.
That's good to hear. Okay, one last signal to cover. Tell me about FRB 18091 speed. It's a repeating FRB, right?
It is. And it's a special one because it repeats on a regular schedule, every 16 days, like clockwork.
A cosmic clock. That's pretty wild. What do they think is causing it?
Well, the regularity of it points to something orbiting something else. Maybe the source of the FRB is in a binary system with a star or another neutron star.
So as they orbit each other, the FRB gets triggered at a certain point in the orbit?
That's one possibility.
Hmm.
Of course, some people have also suggested that maybe it's an alien beacon.
Right, because why not?
Exactly. But most scientists are leaning towards a natural explanation for now.
Fair enough. So we've covered a lot of ground here, from the, wow, signal to these repeating FRBs. What's the main takeaway for you? What do all these mysterious signals tell us about the universe?
I think the bigger takeaway is that we've barely scratched the surface. There's so much out there that we don't understand yet.
We're still newbies in the cosmic playground.
Totally. And these signals, they're like little clues, hints that there's more to the universe than we can even imagine.
And that's what keeps us exploring, right? The possibility that there's something truly extraordinary out there just waiting to be discovered.
Exactly. We just have to keep listening, keep looking, and be ready to be surprised.
Well said. Now, For our listeners out there, I want you to consider this. If just one of these signals turned out to be definitively, undeniably artificial, what would that mean to you? What would it change about your view of our place in the universe?